My work is related to building ontology for Indian music. This is in continuation with what Gopal was discussing. So this is an approach for ontology learning from online music forums. So the objective is to augment the music ontology for Indian music with information extracted from online forums. So we have content-based information in the ontology. So along with that, it is necessary to have information extracted from text data like in online forums and other websites. So, but why we need to have metadata in ontology along with audio-based information? So this is for better retrieval of Indian music information. For example, if we have a query like get all the songs with phrase Nida Nipa and sung by a disciple of D.K. Pattamar. So we have the content-based information in the ontology, but along with that, if we have information, this information which can be extracted from online forums, we will be able to service these kind of queries. So this is the outline. So the work is primarily focusing on resigas.org, and we will be discussing existing work in information extraction, thread title processing, and actual work on relation extraction. As of now, we are doing extraction for named entity recognition and the future work. So our work focuses on Carnatic Music Forum, resigas.org. So the general structure of this forum is that we have subforums in the forum, and there are subforums related to musicological and artist information, and forums related to reviews and audience feedback. So our work is primarily targeting musicological and artist information. The reviews and audience feedback section will require some other kind of analysis, probably some sentimental analysis and things like that, because the content there we have is entirely different from what we have in musicological and artist information subforums. So a few instances from the forum, we have sentences like this Apurva Raga is the Jenny of 28th Melagartha, or this song also has a close resemblance of Misra Pilu or Misra Kapi. So we have to extract information from sentences like this. So the general characteristics of the text in the forum is this unstructured and ungrammatical, and the presence of sentences with less or even no information. And there are sentences which are of interrogative and imperative in nature. So the existing work in information extraction, so Mohammed Sodo and Gopal has done work for extraction from resigas.org itself. So the forum information there is represented as a network representation to identify popular terms within forum, as well as relevant co-occurrences, and thus the semantic relationship between the entities. So in biomedical domain, a lot of work has been done to extract information from biomedical text and journals. So manually and automatically generated pattern-based approach is widely used for structured text. So there is even an approach using a shallow parser and sentence structure analysis technique to automatically extract biological process functions based on a gene ontology from text. So in general web information, there are approaches which learn extraction rules or syntactic patterns, and these rules are used for extracting information extraction. So to get an overview of the syntactic patterns we have in our forum content, so these parse trees are obtained with the help of Stanford parser. So for example, this is a long sentence. This is a long sentence with an information inside that, and this is a sentence which itself has got information. So this long sentence has got Rag Begada has Vakraswaras, and the second one is it's a Madhyama Graha Raga. So here what we can generally see is a NP VP phrase. So NP stands for noun phrase and VP for verb phrase. A combination of NP VP phrase generally contributes to the information. So the NP usually have the subject of the relation, and VP has the verb involved in the relation and also the object of the relation. So before we move to the actual relation extraction, we shall discuss about thread title processing. So here the forums have subforums, and each subforum has got a number of threads. So each thread has got a main topic. So title conveys the main topic of the thread. So what is the relevance of thread title processing? So we have sentences like we saw, it is a Madhyama Graha Raga, or it is predominantly an evening raga. So what does it corresponds to? So mostly pronoun refers to the title of the forum thread or the main topic behind the forum thread, for the forum thread title. So here the anaphora resolution can be done by processing the thread title. So if we take few instances of thread titles, for example, Shanmuga Priya and Simhendra Madhyama, or Chembai Vaidyanatha Bhagavata, which itself is a single topic, or structure of Tillana, where Tillana is the topic here, or difference between Chauga Varnas, Pada Varnas, Varnams. So here we have two topics and a property of the topics. So from the parse tree of these thread titles, a syntactic rule can be inferred. So either it's a set of topics separated by a conjunction, a comma or and, or it's a single topic, or it's a property followed by a preposition phrase and a set of topics followed by separated by a conjunction. For example, the last two belong to this category. So after identifying the topics, we have to resolve the topic, because here we can see that we can see three different instances of Muthuswami Dikshidhar, but all refers to the same person, but with different spelling or different form. So what we have to do to identify the semantics behind the word combination. So we use a dictionary or ontology based approach here to identify the topic. So from the problem is from the thread title in the forum, how do we identify the identity or the semantics of the topic? So we get the topics of the title using the syntactic patterns as mentioned in the earlier slide, and identify the corresponding entry in the dictionary or ontology. So to resolve the topic, what we do is that we get all combinations of adjacent words in the phrase, the unigram, bigram and trigram combinations. So if you have a word phrase W1, W2, W3 in a topic, we get all the combinations like this, and then we do a fuzzy matching with the concepts or concept instances in the dictionary. So as of now, a simple fuzzy matching is used. It has to be replaced by a phoneme based fuzzy matching, where that will be better, because for example, if you have a name Subramaniam, many times it may be spelled as S-U-B-R-A or S-U-B-H-R-A, so it depends upon the users who write it. And we tag the word combination with the identified concepts or concept instance if the similarity with any concept in the dictionary is greater than a predefined threshold. So coming to the actual problem of relation extraction, we use natural language processing techniques to extract relations. So these are the basic steps involved. So we identify the named entities in a sentence. So this is referred to as named entity recognition. So for example, if there are words like Shruti, Hamsadhvani or Purandaradasa, these are named entities in the sentence. And then we find the relation between these named entities. So if we have a sentence like Pramodini Raga is the Janya Raga of 65th Melagartha Raga, Kalyani. So here the named entities are Pramodini Raga and Kalyani, and the relation is the Janya of. So it is extracted as a relation like this. Here we concentrate more on the first step to relation extraction, that is named entity recognition. So I tried with the standard NLTK, Natural Language Processing Toolkit in NEA. So taking a few sentences here. So the green ones are persons, the orange ones refers to organization, and blue ones are location. So here we can see that Subramanya Iyer, Alathur Brothers, Maharaja Swati Tirunal, so these are marked as organization, but actually has to be identified as persons. And even in this case, Alathur Venkatesh Iyer, so this is a single name but identified as two different names. And also we can see that clarinet AKC Nadarajan is only part of it is identified as a name. So this is the problem with standard NLTK NER when dealing with a corpus of this domain. So in named entity recognition, the possible approaches are the dictionary based approaches, there rule based and machine learning based. So we follow a dictionary based approach. So why this approach is better for our purpose? Because our purpose is basically ontology learning. So all the relations involving named entities are to be mapped to the same corresponding instance in an ontology. So if you have different instances of a single name, it should correspond to the corresponding person in the ontology. And we are mostly dealing with Indian terminologies, including Carnatic and Hindustani music concepts, instruments, and this set is limited except for person names. So here the named entity categories are specific to music domain, like artist, instruments, music concept, location. This is different from the categories in standard NER problem, which includes person, location, organization. So this is the basic method behind NER in our case. So we get the noun phrases from the parse tree of sentence in the form. And when using the same n-gram approach which we discussed in the thread title processing, we identify the corresponding instance in the ontology. So here the NER is quite straightforward. So what is the relevance of this n-gram string comparison in NER as well as in thread title processing? So if we take example of these two names, Padma Bhushan T. N. Seshagopalan and Sangeeta Samrat Chitraveena and Ravikiran. So the whole noun phrase doesn't contribute to the name of the artist. Right? So we have to find what is the right combination. So the n-gram helps us to find out which combination has got the maximum similarity with the dictionary we have. So now the identification is quite straightforward, but the problem is how we actually can develop or add to the dictionary. So if the ontology is already ready with all possible instances, it is fine, but that cannot be done. So we have to have some strategy to develop or add to the dictionary. Since the entity is related to music concepts, instruments is a limited set. So the dictionary expansion primarily targets only artist names. A good source is Wikipedia pages under categories related to Carnatic music. So what is the method behind expanding artist names in the dictionary? So the same process, but we identify the named entities of person from Wikipedia sources, that is the difference here, and add it to the dictionary. So there are two approaches as of now identified. There is a bootstrap approach and another approach which we propose for score based on the frequency of component names in the name corpus. So the bootstrap approach, what we do is for a given category of named entities, for example, all the person names, from a set of seed words, initial set of seed words, we identify other named entities in the same category. So this is the method. So we define a set of seed words, for example, a set of artist names, and from the given corpus, in this case a Wikipedia corpus, we extract all the verb patterns in the corpus, and then we score the verb patterns based on the occurrence of these verbs with the already existing seed words. So we add the existing seed words to the lexicon. So lexicon is what we get us the output, and then get the top 20 plus I verb patterns. So I will get incremented every iteration, and with the help of this top ranked verb patterns, we identify some more candidate words. So we already have the seed words in the lexicon, so we identify more candidate words and then score these candidate words based on existing words in the lexicon, and then we add the top ranked candidate words again back to the lexicon. So when this is iterated for a fixed number of times, we get another set of candidate words or another set of lexicon which are basically person names. So this is when we tried this method with the Wikipedia corpus with a good number of seed words. So we could extract additional relevant candidate words this much. Actually, there are some more words which are not relevant. So actually, in this case, we made a slight change to what is mentioned in the papers. In the paper, they use actual verb patterns, but we used a dependency parser and tried to analyze the relation between the verbs involved and the nouns instead of taking a verb pattern as such. So I'm still working on it to figure out what exactly is the problem or how it can be improved for our named entity recognition. So this is the second approach yet to be tried. So we score the names in the database. We already have a set of names in the database which probably can be extracted from with the help of info boxes in Wikipedia. So because info boxes will give a clear idea about whether a page is about a person or not, and in Carnatic music category. So for example, we have clear information about a person in the info box, like you see here in the Wikipedia page. So if we have a fixed set of names, for example, if we have, in this case, we take two names, Muthuswami Dikshidhar and Ramaswamy Dikshidhar. So the components are Muthuswami, Dikshidhar and Ramaswamy. So here the score of Dikshidhar is greater than the other two words because Dikshidhar has got more co-occurrence with other name components. So in this way, we do a simple scoring of the words of the name components of the names we have in the names corpus. And when we get a new noun phrase, how do we decide whether that noun phrase is a person name or not? So what we do is that we get the components or the words involved in the noun phrase, and say for example N1 to NL, and we score each. We know the score of each word, and then we do a summation of the names, and actually we have to do a normalization also based on the length of the noun phrase. And NP is acceptable as a name only if the score, the overall score of NP is greater than a threshold. So we discussed approaches to enable dictionary-based NER as a way to relation extraction. So here the specifics of the domain helps us to reduce the complexity of NER as compared to NER in a normal web corpus. So here the dictionary-based expansion approaches are to be compared. So we have to compare the efficiency of the system as well as the amount of information it can extract. So future work has to be done in relation extraction and mapping the extracted relation to the predefined set of relation. Why this is required? Because from a forum like resigas.org we get quite a lot random relations which have to be mapped to standard relation, because our main purpose is to augment these relations to the existing music ontology. So we cannot randomly populate the ontology with some random relation. So that's it.